You are watching the MPiec Web UI video tutorial series. In this video, we'll use the motion control panel to run a test move in order to verify that the controller can run each servo axis. Hi, I'm Matt Pelletier. Here's a quick preview. After all servo alarms are cleared, stop the controller program from running and use the Java-based motion control panel to enable the servo and set a new target position. Now let's go through this in more detail. To follow along in this tutorial, you'll need connection to one of our MP3300 IEC and Sigma 7 demo units. If you would like remote access to one of these demos, please request by email to training@yaskawa.com. You can see how this works in the remote connection e-learning video. First of all, the purpose of the test move is to confirm that the controller can successfully command motion without relying on the controller program. When the test move succeeds, then the servo amplifiers and motors are functioning. Any issue, therefore, must be in the controller program, input sensors, or other upstream devices such as a PLC or HMI. But if the controller cannot move the motors, then there might be a problem with the wiring or with the parameter configuration of the servos. A detailed procedure for running a test move through the Web UI is given in the Quick Reference Guide, section 1.I. Now, I'm assuming that you have already restored the demo system using the project archive as shown in the previous tutorials and that you've cleared all the servo alarms. If not, I recommend that you follow through those tutorials first. I'm connected remotely to the demo, and so I can confirm this, that I don't have any alarms. And also the Web UI confirms that I don't have any alarms right now. Back to the Quick Reference Guide, the next step says to stop the controller program, but I'd like to show you what happens if you rush ahead to step 4 and try to directly control the motors without stopping the controller program. So back now to the Web UI. Under the Operations menu, you can open the Motion Control panel. And as we've done before, you click Download and Run Externally, assuming Java is already installed. Keep and launch this applet. The first step you would like to do is to enable. And I'll click this box to enable, but notice that it won't work. And the reason it won't work is that the controller is running. And we can see that here, that the controller is ready and the run light is on. So it should come as no surprise then that the code is running and it's not permitting us to enable the servo. Whatever logic controls the servo is right now disabling the servo. So this is why it is important to first stop the controller program. So we could turn on the stop switch if you had physical access to the controller, and then this run LED would turn off, and we could then use the Web UI. However, we can't do that remotely. We could use the MotionWorks IEC resource panel to stop the controller, but one way to test run using just the Web UI is to temporarily delete the archive and reboot. So let's do it that way. We can close this window, and now under Setup we can go to the archive. You would first want to receive the archive so that you can put it back later after the test run. This demo has been set up with the provided archive, so I'm just going to go ahead and delete it. We can always restore that later. We'll delete the archive, and now reboot the controller. Hit reboot here. And now the controller is rebooted, and you notice that the ready light is on, but the run light is not on like it was before. So we have completed step 3, stop the controller program, basically by deleting it. We can now go and do step 4, open motion control panel like we did before. Under Operations, motion control panel, run externally, keep and launch the applet. Now that we're in this applet, we can enable the servo. I'm going to start with axis 5. Notice that the name of the axis has been lost since the archive is gone. Another interesting fact is that the velocity and acceleration have returned to the default configuration of revolutions. So this is 1 revolution per second and 1 revolution per second squared. It previously was set to 360, as that was the conversion between revolutions and user units in the project archive. So we are ready for step 5 now to move the motors. And why don't we start with axis 5 since it's already enabled. Notice the feedback position in rotations. Velocity and torque is given also. And now the target position. This is all working in absolute position. I recommend you start with a small amount, such as changing one digit here, increment the 100th digit from a 4 to a 5 in this case, and then just click move and keep your eye on the motor. Okay, so that was 100th of a rotation. You can change this 0 here to a 1 and click move. That's 1/10 of a rotation. And if you change this 2 here to a 3 and click move, a full rotation. We can do the same thing for axis 3 and 4 and enable axis 3. Let's give it a position of 1 and move. That worked. And here a position of 1 and move. That also works. It's usually not necessary to change the velocity or acceleration and deceleration. The defaults given are enough for a test move, but feel free to play around with this. And I'll play it safe and do a 0.2 on this one and a 0.4 on the other one. Click move. And you can see that nothing really happened. It's a common misunderstanding. This is not an incremental position. This is an absolute position. So you got to compare to your feedback. If you want to go another rotation, go another 2 here. Let's go to position 2 and hit move and move. Sometimes for a test move, you simply need to make the motor jog slowly. And for that, you can go to the velocity control mode, set your target velocity, and you need to also set a target torque. If you leave it at 0, tell it to move, it won't move. And what this really is a torque limit. So let's limit it to 5% and try that move again. Looks like 5% is enough to move this motor. Now we're just moving pretty much indefinitely at this speed. And to stop it, you click abort. Some common mistakes when using this interface. Number 1 would be forgetting to enable the servo and then attempting a move. There we go, let's try move to 3 and hit move. And that one's pretty easy. It'll tell you the axis is disabled. So you need to enable it and move. Another one I already mentioned, which is thinking that you can click move multiple times without changing the target position. And then number 3 would be if you have a correct position, you have it enabled, and you click move, and it still doesn't move. Maybe you can tell here by looking at the video screen what's going on. You see the servo amplifier is flashing PN, and while that is not an axis alarm, that is because here I paused the video and I disconnected over travel connections, pot and not over travel. So let's connect those again, and now I'll be able to do that move. Now finally, a really important part of the test move is to do step number 6, run the controller program. If you had turned on that stop switch, you'll need to turn it back off and reboot the controller. And in our case, we'll need to install the saved archive and reboot the controller again. So let's run through that and just go back here to the archive where we started and send, add archive, and choose the archive that was supplied with the class materials for this training. You click open and send like you've done before. We'll install with clean install. Now we see the files are back here in the project archive, so we can reboot. And about 30 seconds later, we have both ready and run LEDs, indicating that the controller is running its program again. It's a good idea to refresh the applet. That just means close it and open it next time you need it. So we will close the engineering tool, and we're ready to use the demo. I now invite you to play around with the test move on the demo until you're confident with each of the functions. Thank you for watching this video, and remember yaskawa.com/IEC for more information on the MPiec product line.